smart city development, there is a huge amount of energy is required, and for that, renewable energy may be used effectively, and sustainable development must be carried forward. So all this aspect has to be covered by our panelists. So move ahead. Now I request Professor S.K. Kalla sir, Chairman Electric Energy Division Board, to address the gathering and motivate us. Sir.
Yeah. Good afternoon to everybody.
Good afternoon.
And it is a very relevant topic chosen by the Surat Local Center. And I know that a lot of innovations, etc., are going on this topic. And still, there is a lot of scope in carrying out of this. The panelists what you have got collected are very renowned. And I think this webinar is going to give us a very good guidelines and the solution and conclusion so that we can work on this smart city and IoT topic in a right way. So all the best, have a nice time, and we are going to have a great thoughts from the panelists of this webinar. Thank you. Go ahead.
Thank you, sir. Thank you. So friends, welcome to this technical webinar. Respected Thakre sir, Chairman Kate Ranganath sir, Kalla sir, from Chairman Electrical Division Board. Let me introduce today's two panelists. We start with Dr. Vishal Sandwar. He is an assistant professor in Department of Chemical Engineering, Parul Institute of Technology, Barodra, Gujarat. Dr. Vishal has completed his BTech degree in Chemical Engineering from Gandhi Institute of Engineering and Technology, Gunupur, under BPUT, Orissa. He is also qualified in GATE in the same year. He has completed his Masters of Technology from Department of Chemical Engineering from IIT Guwahati in the year of 2014. And he was awarded PhD degree from Department of Chemical Engineering IIT Roorkee in 2018. He is currently associated as an assistant professor in Department of Chemical Engineering, Parul Institute of Technology, as well as he is Institute Coordinator for Research and PhD at Parul University, Vadodara. Vishal is having almost 4 years of experience in academics. His research area includes wastewater treatment, waste to energy conversion, catalysis, nanotechnology, etc. He has also published 8 research papers in Scopus as well as SCI index journals and others in non-SCI journals. He has presented many papers in national and international conferences as well. He reviewed many research papers from various journals of elsewhere, Springer and Taylor Francis, etc. He is working as objective lead and co-PI in the international project funded by Royal Academy of Engineering, UK. He organized many events such as International Conference, PICET 2020 as a co-chair, Grand Global Challenge Summit 2019 as team lead, his IPR workshop as a co-coordinator, Tech Expo as a coordinator, etc. Dr. Sandwar received Teaching Excellence Award in 2019 from Parul University. We are very happy to have you, Dr. Vishal.
Thank you.
Now, moving further with our second panelist, Dr. Gaurav Pandey. Dr. Gaurav Pandey is an assistant professor in Department of Petroleum Engineering and Earth Sciences at University of Petroleum and Energy Studies, UPES, Dehradun. He holds a joint PhD degree from IIT Madras and National University of Singapore under the supervision of Professor Jitendra Sangwai from IIT Madras, as well as for Professor Praveen Linga from NUS Singapore. He obtained his master's in petroleum engineering from IIT Madras. Dr. Pandey received the prestigious Bhagya Lakshmi and Krishna Iyengar Award for best PhD thesis or project research work at IIT Madras in the field of alternative energy application. He also received the Institute Research Award for the recognition of quality and quality research work conducted at IIT Madras also. His research interests areas of collected gas, hydrates, SNG, energy storage, and transport of fuels, flow assurance, rheology, carbon dioxide capture, storage and utilization, enhanced oil recovery, drilling fluids, and oil and gas technology, etc. He published 2 book chapters and 8 peer-reviewed papers in international journals and 14 conference proceedings of international repute. His journal citations are around 200 with H index of 7 and I index of 6. Dr. Pandey attended many conferences and gave the oral talk in US in ICGH 2017, CMTC 2019, as well as Singapore, WESUE 2017, Mauritius, Japan, and in India also in various IITs and renowned colleges and universities. Dr. Pandey is also a reviewer of Applied Energy, Impact Factor 9.7, Journal of Natural Gas Science and Engineering, Energy and Fuels, ACS Omega, etc. He is also having a MHRD fellowship and NUS research scholarship during his PhD journey. Dr. Pandey is also a member of American Chemical Society and Society of Petroleum Engineers. Friends, definitely this webinar will emphasize the sustainable and smart solutions for the waste management as well as for energy conversion or renewable energy solution for IoT based smart city. Without further taking more time, I invite Dr. Vishal to have their expert presentation. Dr. Vishal, please, over to you. Thank you.
Thank you so much, sir. Is it visible, sir?
Yeah, visible. You can move ahead.
Okay. So thank you so much for the introduction. Good afternoon, one and all present over here. Myself, Dr. Vishal Kumar Sandwar, and I'm assistant professor in chemical engineering department, Parul Institute of Technology, Parul University. So first of all, I'd like to show my sincere thanks to the Institution of Engineers, South Gujarat Local Center, for providing me the opportunity to deliver the talk on sustainable development and renewable energy, IoT-based smart city infrastructure, and its application model. So, as we know that the smart city mission was launched by the Indian government in the year of 2015. So the government had launched the project for developing 100 cities as a smart city. So the fundamental objective of the government of India was to just develop or progress for the ambitious program that aimed for the developing citizen-friendly and self-sustainable urban settlements. So basically, for that objective, this means for the development of good governance, citizen-friendly environment, sustainability in almost all the area. So a smart city comprises the different key components, which are, you can see smart people, which includes smart education, smart health, smart medical, smart entertainment, cultural activities. In a smart mobility section, it includes smart traffic management, smart transport, walkability. If we talk about the environment, that is smart environment, one of the most important or key component of a smart city. So it consists of pollution, smart building, and renewable energy. So energy is very important aspects and smart city, because the more focus is to give they want to use the energy from renewable sources. And in a smart economy, so basically the target was to just provide abundant opportunities in the sector of employment. In smart governance section, so IT connectivity must be there, online citizen services must be there. And now the crucial part, one of the most important thing like smart living. So in this part, several points are mentioned like citizen safety, housing, electricity, public open space, and finally water supply and sanitation. So smart water and wastewater management is one of the most important and crucial part of a smart city. So as we can see that on the screen, like the different zones are mentioned with a different color. So in the different colors, you can see the condition, the present position of water in our country. So the white color indicates the safe zone in India. The yellow part indicates about the critical zone. Uh, the purple part explain about the semi-critical zone. So you can see that. So because what is going on due to the rapid urbanization and globalization, so the freshwater resources are becoming increasingly scarce. So now today more than 1 billion people, based on the WHO report, World Health Organization report, more than 1 billion people do not have access to clean drinking water. So see the condition, even in our country in 2019, in Chennai, it was like Chennai was the witness for the scarcity of the drinking water. So we can see the condition, we can just see think for the future like the crisis of water due to the rapid uh, population, rapid increase in population. Now, these are the data I have just taken from the Ministry of Water Resources, like what we have right now, what are the available resources, estimated utilizable water. So we have total 1,121 billion cubic meter water available, which if we segregate this water, surface water ability is around 690 billion cubic meter, then groundwater is around 431 billion cubic meter. Now, what are the key challenges in India? Let me see, according to the data collected by the World Resource Institute, India ranks 13 among the world's 17 most water-state countries, with more than 80% of its available groundwater withdrawn. India's surface water is highly contaminated. Means even we have a huge amount of water, like we have 70% of water in surface, but that water is not able to drink. So we are not able to drink such type of water because the contamination is there. If we, in the seawater, the high amount of TDS, high amount of salinity is present. So without treatment, it is not possible to drink such type of water. Furthermore, nearly around 40 million liters of wastewater enters India's river and other water bodies every day. So, and a very small amount is being treated nowadays. This is a very major challenge which compounds India water crisis and further affects its already dwindling freshwater supply. So the current scenario highlights the need for a focused and a strategic long-term approach for the management of water in India. So basically the most important challenge in this sector, like I'm just giving more emphasis on the wastewater and water, groundwater availability. So we have groundwater, but due to the high population, huge population, the consumption, the depletion of water is very high. So we need to think in that way. We have to just provide a sustainable solution for the water conservation as well as for the wastewater treatment. Now, access to water is a key building block of infrastructure in smart cities. As cities grow, there will be a direct impact on the consumption on their water, means consumption of water consumption as well. So we have to just think on the sustainable water management, which comprises basically water catchment and water preparation. What means like we have to do groundwater monitoring, water catchment, water preparation. So now we have to just utilize in a smarter way. We have to use the smart solutions as we will discuss, as I will discuss further, like what is the smartest solution nowadays. SCADA is using for the water management, wastewater treatment. IOT sensors are being used in very large amount. So we have to think the sustainable approach in a more smarter way. Wastewater treatment is one of the most crucial and important thing for sustainable waste management. Like nowadays, the existing plants, that if whether it is effluent treatment plants or sewage treatment plants, we need to just upgrade that plant, because I will show the data like how much amount of water, municipal wastewater we are being used in India. We are being treated in India with the help of STPs. So in wastewater treatment, I mean, we have to just think about the municipalities, municipal wastewater, agriculture wastewater, industrial wastewater. We have to develop an efficient, cost-effective, and effective technology for the treatment of such type of water, because huge amount of wastewater is generated per day. And uh, if suppose we have 100% of water, so we are able to treat only 30 to 40% of wastewater. So even we are not capable to treat 60% of wastewater. If we will be able to or capable to treat such type of wastewater, such amount of wastewater, then it will definitely help. So for that, uh, we have to just provide a sustainable solution. Sustainable solution plays a great role in this concern. After that, sludge treatment in water, energy management. Now, what is going on nowadays? Researchers are doing a lot of work in wastewater treatment. They are using a number of technologies. Simultaneously, they are utilizing the energy from the renewable sources. It's like I can say that even in the treatment, wastewater treatment, the researchers are producing energy, means simultaneous energy generation as well as water treatment. So number of research are going in, and we have to just implement that solution in practical way. So energy is one of the most important thing. And in wastewater management, we can just use such type of energy sources. Like in wastewater, we can just we can have the growth of microalgae, and microalgae is the second generation fuel and next generation fuel, biofuel. So we can utilize the energy to operate the wastewater plant. In water distribution, the components of the water distribution system, water supply network, and sewage system, we have to just develop, as I told, we have to just develop an efficient and cost-effective technology, water efficiency technology in the household itself. So these are the things we have to just for making it sustainability in providing sustainable solution in smart city. We have to just adopt such type of smarter solution. Now, role of sustainable water management in a smart city. So, according to the report of United Nations, India is expected to have more than 60 cities with over 1 million population and 6 mega cities with over 10 million population by 2030. Even right now, we don't have sufficient amount of water for drinking purpose. So you can see the scenario in the future, like means like by 2030, there is an increase in the like 10 million population. So it is a very big role or very big concern. We have to just do in very effective direction. It is important to provide this access to the resident in a sustainable manner by a streamlined water processes, exploring alternative to the conventional methods of consumption and minimizing wastage. So either we have to just minimize the water consumption or energy consumption, or we need to just develop such type of technology by which if we can have a abundant amount or sufficient amount of water for its utilization. For such type of sustainable management, we can have the IOT, artificial intelligence, a big data, and with the help of such type of solution, we can have a smarter or sustainable plant or technology or methodology for wastewater or water treatment. So currently, India has the capacity to treat approximately around 37%, as I told. Even we are not using our 100%, like 37% of the total wastewater generated in the country is being treated. So smart cities can adopt a circular approach for reusing water multiple times to reduce their dependency on fresh water. We must develop such type of technology, because the scenario of groundwater is getting worse day by day. So we need to just develop we need to work on the water conservation. We need to work on the efficient wastewater treatment technique. So this is very big concern, and we need to think over there. Individuals and organizations can also establish wastewater process in their buildings at varying scale on the basis of their respective volumes. So Singapore has been able to successfully adopt a smart wastewater management to meet 40% of their water demand. So in that line, even in our country, things are going on. It's like modifications are upgrading of STPs and ETPs are going on. But like we have to just also utilize the digital, the innovative techniques to upgrade the existing plants. Now, smart wastewater management. Cities are introduced to the smart water, the points that that points to water and fully fledged wastewater infrastructure, which ensures effective management. So, as I haven't discussed, like SCADA we are using a SCADA software and SCADA tool for the wastewater management, but it has some limitations. Like it is difficult to install. It has some higher cost, and it has some maintenance issue. So we have to think to provide. We have to think in such a way that we must have some effective and efficient technology. That technology, like if we are giving solution must be user friendly, or solution must be economic or effective. Nowadays, IoT has a great role in wastewater management and wastewater treatment. So IoT, Internet of Things technology, is a smart concept to enable reliable communication between wastewater management system and administrators. So even I have seen from since last 7 or 8 years that IoT sensor are being used in sewage treatment plant or if effluent treatment plant. So what IoT sensor does? IoT sensor that basically predicts the limit, the set value of the parameters in the wastewater or water. If suppose I'm saying that water having the different properties like the COD, chemical oxygen demand, biological oxygen demand, pH, total dissolved solid, total solid, phosphorus, nitrogen. So with the help of IoT sensors, we can have idea. We can collect the data from the IoT sensors to the cloud, and after collecting the data, we can analyze them, and we can decide a proper and efficient solution. So nowadays, it is IoT technology becomes a cost-saving and efficient way to operate a wastewater treatment plant. Moreover, it is an effective way to identify potential areas water uses and take actions accordingly to minimize the same. The IoT sensors are capable to detect, as I told, the combined sewage place. Now, even in groundwater section, we can just, if we supply water to the pipe, like we can detect the leakage. So with the help of IoT sensor, we can regulate the flow of water if we supply water in continuous way. So we can just find out the data from the IoT, real-time data from the IoT sensors. And leakage is one of the biggest problem to supply water in urban areas. So the problem can be solved through this IoT sensors. Now, planning of water management in smart cities. So there are multiple factors, and which I will discuss here, like for the proper planning and implementation of a smart or intelligent type water and wastewater management system that basically comprises accessibility and optimal utilization of resources. We have whatever we have the resources, we need to just utilize in optimized way. Like we know the groundwater condition is getting worse day by day, so we have to just utilize in optimum way. It is very important. Like as I told, for instance, in 19, the Chennai witnessed severe water scarcity with all its reservoirs running dry in the summer. So now they have just come up with a solution, and they're actively working towards the adopting the sustainable water process. Right? Uh, they have adopted the newer technology. They have utilized the innovative and sustainable approach for the water and wastewater management. So several proactive measures, including steps to improve the distribution network, uh, desalination, wastewater treatment site, and water metering, that can have a positive impact on current wastewater scenario. So we have a limited amount of resources, so we need to use in very optimized way, anticipating future demand. As we know, and I have just shown that in future, what would be the population rate. So even we have to just calculate, we have to just think to provide in the future, like what would be the demand in future if population is being increased by this rate. So what would be the demand in future? So we have to work on that part also. So anticipating future demand, offsetting the impact of climate change. We have seen the uh, effect of climate in past 10 years, past 20 years. Like if means like if I will just select some uh, section or part of the country, like there is a huge amount of water, ability of huge amount of water, and somewhere there is a scarcity of water. So based on the climate change, based on the geographical locations, we have to work we have to work in more smarter way, and ultimately uh, the effective wastewater treatment, it is very important part. And because this we have such type of water, we have wastewater, so we have waste material. Now we need to just convert that waste material into valued product. We have to develop such type of technology which must be cost effective, efficient, by which we can convert, we can remove the contaminants present in the wastewater to more effective way, by which we can just get the pure water. So we have to think in such a way. We have to things are going on. The existing plants are working on this part, like they are developing a smart solution for wastewater treatment and other things. So sewage treatment plant, as I discussed, like the municipal wastewater, the wastewater coming from the household and the local communities is being treated by the sewage treatment plant. And the second part is industrial treatment plants, ETP, effluent treatment plant, that basically treats the water coming from the wastewater come from the industry section. So now I'm giving the more emphasis on the sewage treatment plants. Sewage treatment plant, as you can see that the comparative statistics on the inventory for the year of 14 and 20. So recently and currently we have around 1,469 sewage treatment plants in our country. Out of them, 1,093 sewage treatment plants which treat the municipal wastewater, the water which comes from our household, means the local community. So the operational treatment plants in our country, from I have taken the data from the Central Pollution Control Board. So based on that, it is around 1,093. So actual utilization plant is 1,093, compliance around 578, non-operational 102, under construction is 274. And in the last column, you can see that the capacity of water, wastewater. So every plant has its own capacity. So the capacity is mentioned in millions liter per day. So nowadays we have in India like 31,841 millions liter per day capacity for the treatment of sewage water or sewage, municipal water. So, but due to the increasing population, the high growth rate in the population, we have to just construct more and more plant, and it is very much required to treat more amount of municipal wastewater, as we have to just increase the capacity of the existing plant by the utilization of IOT sensor or smart solution, because ultimately we are providing some sustainable approach sustainability is one of the big issue nowadays. So for for developing a smart city, it is very important that water and wastewater treatment plants must be smarter, that works in more smarter way, because we have already the existing sewage treatment plants or effluent treatment plants. But if we are developing a smart city, so things will be little bit smarter. So either we need to just decrease the time of treatment, the cost of treatment, and we want to get the more purified water. So we have to just do in all the aspects. We have to work in all the aspects. This is the current scenario of water or wastewater, or more precisely, I can say that the sewage treatment plants in our country. Now, what are the technology which are being used in sewage treatment plants? So this is basically various physiochemical process are being used, such as coagulation, flocculation, adsorption, sedimentation, filtration. So various technologies are being used in this particular section. Sequential batch reactor, biological process which comprises aerobic, anaerobic process, membrane technology, which is considered as a green technology and very useful and very effective technology for wastewater treatment. Nowadays, almost means like all the existing plants are taking this type of technology for the enhancement in the quality of the water. Electrochemical process, various electrochemical process such as electrocoagulation, electrophenton, peroxycoagulation, electrodialysis are being used in extensive way. So these are the technologies which are being used in the existing plants. Now I have just shown this table. This is the current status of sewage treatment plants in Barodra. Barodra is also listed in a smart city. So total 8 STPs are present in Barodra, and each and every different techniques are being used. And most of the plants, activated sludge process, this is a kind of biological process, are being used for the treatment of sewage water or municipal water. So you can see the technology used for the treatment, the installed capacity. Like in some of the plants, the capacity is around 66 MLD, 52 MLD. MLD means millions liter per day. So having different technology, Barodra is this is the current scenario in Barodra. Now, what are the problems? Why we need to go for more smarter solution or sustainable solution? So there are some problems associated with the conventional treatment plant, like high treatment cost, energy requirement. As I told, energy is one of the biggest issue. So can we just implement such type of technology by which we can generate energy during wastewater treatments? The things are going on. Like countries like European countries are already doing this type of things, like they are treating water, wastewater, and simultaneously they are generating energy. Like researchers are extracting the hydrogen from the wastewater, or they are doing the cultivation of microalgae in the wastewater for the treatment. And after that, after cultivation, harvesting of microalgae, they are extracting biofuel from that, which is also a very big solution in the case of renewable energy sources. So we have to just adopt a smart and hybrid solution, which must be sustainable and cost effective. Now in membrane, like if we use membranes, so fouling is one of the biggest issue. Like we have to just internal fouling, external fouling is one of the biggest issue in membrane separation process. Now, what are the required salient features for wastewater treatment? So basically, based on the existing plants, I can say that we have to just adopt the process which is in continuous way. Or we are developing a smart city, so we have to just use the green technology. The methodology must be green, that must be eco-friendly. As I told, energy generation process, simultaneous energy generation process must be there. Low sludge generation must be there. Low fouling, and ultimately a smart data collection. Means we can develop automatic, smart, efficient plants. Now, what are the emerging sewage treatment technology? So as I have shown the existing technology, like in different plants, they are using sequential batch reactor. So this is basically activated sludge type of treatment, and which combines primary settling, aeration, secondary settling, and decanting the treated sewage in a series of sequenced reactor. After that, moving bed biofilm reactor, where we just implement the other media that basically provide the high surface area, and we will get the high efficient means like efficient wastewater. And one of the most important technique, membrane bioreactor. It is very, that is also the combination of like secondary clarifier or activated sludge process and membrane technology. Number of emerging technology are already being used, but we have to just develop or put some extra effort. We have to just like integrate this IOT sensor or either SCADA things or other things to make the plants more smarter. So biofor technology, submerged aeration technology. So these are the emerging technology as mentioned by the Ministry of Urban Development. So in if we see, so as I shown you the condition of Barodra Municipal Corporation, so they are using a sequential batch reactor, which is also very good and efficient. So this, the layout is of submerged membrane bioreactor. As I told, membrane bioreactor, like it is the combination of membrane and bioreactor, activated slurry process. So in activated, what happens in activated slurry process, like the microorganism present in the water, that will basically eat the contaminants, the pollutants present in the water, and then we use generally the diffuse aerator to provide the oxygen to the microorganism, and after that we just pass the that water to the membrane, and we will get the treated water. So this is very much efficient technique, and recently we have proposed, we have got a fund from Royal Academy of Engineering and the proposal entitled AI and IoT digital technology for smart cities. So I am actually working as an objective lead for the smart waste management, smart wastewater sewage management. So we have proposed some hybrid or smart type of membrane bioreactor technique. So because the ultimate aim is to get a high efficiency, as you see, it does yield a treated sewage with practically no BOD and suspended solids. So our target is to get purest water in least cost. So these are the design quality parameters. So if we collect the water, municipal wastewater, to what is the initial characterization, like what is the pH, what is the BOD, COD. BOD stands for biological oxygen demand. COD stands for chemical oxygen demands. So basically, what are the initial characterization? Now, after treatment, this is the standard given by the CPCB, Central Pollution Control Board. What would be the BOD after treatment? So we need to just achieve that goal. Like BOD must be or less than 10 milligram per liter, COD less than 50 milligram per liter, total suspended solid less than 10 milligram per liter. So for that, we have to just adopt a sustainable and smart solution. So there are some pros and cons of MBR, like it gives high quality water, it has compact system, and it gives a high efficiency. Now there are some disadvantages also. It is not possible to cannibalize the system between different manufacturers, like high reliance on energy input. It takes energy. So we proposed, even in our project, we proposed we want to operate our reactor based on the collected biofuel from micro-algae. So we have to think in that direction to obtain or to get a sustainable approach in this smart water and wastewater management. We have to do a lot of work here, and previously a lot of things are already going on, but the things must be in proper way. So thank you so much.
Thank you, Dr. Vishal. Thanks for your expert session. Now let us invite our next panelist, Dr. Gaurav Pandey. Dr. Gaurav Pandey, over to you, please. You can start your session. Thank you.
Thank you, Professor Pancha. Am I audible? Am I audible?
Yeah, you are audible.
Okay. The slides are visible to all of
Yeah,
you.
visible to all. Let's make it okay. Everything is good now.
Okay, fine. So, very good evening to all of you. Is this panel is creating problem to all of you, or is it fine?
It is all okay. You can move ahead.
Yeah, fine. A very good evening to all of you. Professor Panchal, the Institute of Engineers, other panelists, audience, and the organization. So today I'm going to discuss about the natural gas hydrate, innovative technology in the field of clean energy storage, as well as in the field of renewable energy, as well as the sustainable energy. So I am Dr. Gaurav Pandey, working as assistant professor at University of Petroleum Energy and Studies, Dehradun. I hold the joint PhD degree from NUS Singapore and IIT Madras. So this is my educational background, already briefed by the professors Panchal, and I hold the Bhagya Lakshman Krishna Iyengar Award for the best PhD research work. Also, I hold the Institute Research Award. I received various grants from the UPS University, and I also hold the various prestigious scholarships. My research interest on the gas hydrate, energy storage, clean energy, CO2 sequestration, all also in the field of oil and gas industries like drilling fluid, enhanced oil recovery, and nanotechnology. I'm also serving as a reviewer in various prestigious journals, having an impact factor of around 10, 5. So let's discuss about the where do we get our energy. So we have a pie chart from where we can get the we can see that we can get the energy in the field under different terms of the fields like coal, biomass, petroleum, natural gas, nuclear, hydropower. So our focus is based on the natural gas. So why the natural gas play an important role? It's significant. So according to the International Energy Agency, this century is called as golden era for natural gas. If we look at global scenario, the share of natural gas is highly significant as compared to the total energy. However, this energy data is from the World Energy Outlook by 2013, but there's not so much difference in 2021 also data. So we have to focus on the natural gas. If we look at from the Singaporean scenario or the other country scenario, but the share of natural gas or usage is very high. So there is a need to develop a technology to store the natural energy, natural gas. So we have conventional method. So let's discuss about the energy storage point of view. If we look at the Singapore story or the other countries' story, the storage of energy via two methods via two form, molecular form or the form of electrons. If we look at in the molecular form, we can store the natural gas in the form of SNG or CNG. In the form of electron, we can store in the energy in the form of batteries and the capacitor. But there are a lot of challenges we are facing with the electrical energy via the batteries and capacitors, like poor conversion efficiency, high material cost is associated, and there's a large scale storage, one of the major challenge. And if we look at the conventional method for the storage of natural gas, we have two conventional methods, as we are familiar with these two methods like CNG and the LNG. But there are a lot of challenges. If we look at the LNG point of view, LNG requires extreme low temperature to store the natural gas, like -161 degrees Celsius. And if we look at the point of CNG, it requires very high pressure, around 200 to 300. So there are a lot of challenges are associated and along with the risk. So we have to move towards the another technology that is called gas hydrate. So gas hydrate achieved a high significant contribution in the terms of energy or attentions by the industry people or in the oil and gas industries from the rated point of the flow assurance, from the point of energy storage, or from the point of seawater desalination. Am I audible? Yeah. Am I audible?
Yeah, you are audible, doctor.
Okay. So gas hydrate is one of the emerging technology. As my title talk is innovative technology. So emerging and innovative technology in the field of clean energy. Why we call it the clean energy? Because natural gas emits only half of the carbon emission as compared to the other fossil fuels. So the gas hydrate play an important role in the future as a potential source of clean energy. What are the gas hydrates? Gas hydrates are made up of water molecules and the gas molecules, where these water molecules are known as host molecules and these gas molecules are called as guest molecules. These are similar to ice-like crystalline compound. That's why we also call burning ice. If you look at these three figures at the molecular level, we have the water molecules. You can see these are the water molecules and we have the gas molecules, right? This is CH4, methane, basically. So that's why it is called methane hydrate. If we look at from the naked eye, it looks like ice-like crystalline structure. And when the stability of hydrate disturbed or the condition, the phase equilibrium conditions are disturbed, or if we just ignite it, it starts burning, or we can say the gas comes out from these cages. So this is called as burning ice. So what happens at particular or the suitable temperature and pressure conditions, water molecules form the cage-like structures, and in these cages, the gas molecules resides. So you can see, we can see that the CH4 molecule has resides. So typically, the gas hydrate stores in 1 meter cube of gas hydrate, it stores 160 to 180 meter cube of gas at standard temperature and pressure conditions. Where these gas hydrates found? These gas hydrates are exist in permafrost region, the cold areas, oil and gas wells, pipelines, and subsea pipelines. So generally, these gas hydrate forms at low temperature and high pressure conditions. If we look at this worldwide distribution of gas hydrate or the figure, so you can see the gas hydrate evenly distributed around the globe, and we have the blue triangle represent the gas hydrate recovered, the red circle represent the gas hydrate forward, and there are a lot of fields which is discussed in this paper from where we have taken this image. So if we can say that the uniformly or the evenly distribution of gas hydrate around the globe, we can say that gas hydrate has potential source of energy in the worldwide, or it is a source of clean energy. Typically, the gas hydrate structures classified into three structures: structure 1, structure 2, and structure H. These structures based on the gases molecules. So if you look at here, we have one this hydrate. We have the water molecule cages, we have the gas molecules, and we have 2 small cages and 6 large cages. If we talk about structure 2, we have 16 small cages, 8 large cages. And if we talk about the structure H, we have 3 small cages, 2 medium cages, and 1 large cages. And all these structures depend on the gases molecule size. I just want to let you know that the gas hydrate formation is a random process, is a stochastic process. The formation of gas hydrate is a random process. Let's talk about the gas hydrate applications and significance. If we talk about from the point of application, we have 4 major applications, like solidified natural gas. If you look at the previous slide, here the naked eyes picture, you can see the gas hydrate looks like ice-like structure, it looks like solid structure. So that's why it is called solidified natural gas. We can store a large amount of gas in the form of gas hydrate. As I discussed just now, in the gas hydrate, only the water molecules and the gas molecules participated. If we look at it from the point of seawater, if we use the seawater for the formation of gas hydrate, only water will participate. So we can say that we can do this, we can achieve the seawater desalination process also. If we talk about the hydrogen storage point of view, as the hydrogen is one of the clean energy, so we can also store the hydrogen in the form of gas hydrate. Another example is CO2 sequestration. As now world is more focusing about the CO2 sequestration, carbon capture techniques, and for the long-term storage. As I discussed, in the natural gas hydrate, we can store any natural gas, either methane, propane, CO2, any natural gas, hydrogen. So if we achieve the phase equilibrium condition for the CO2 hydrates, we can also capture the CO2 in the form of hydrate. That means the water molecules from the cage-like structure, and these CO2 molecules resides in these cages. And once we can capture, or as we know, under the seabed, we have achieved this temperature and pressure conditions, and we can also store the CO2 over there. So CO2 sequestration is one of the major application of this gas hydrate. So let's summarize: energy storage, seawater desalination, hydrogen storage, and CO2 sequestration. If we look at from the point of energy point of view, as I discussed, the gas hydrate evenly distributed around the world. So we can say that it can supply 1,000 years of energy, till 1,000 years. Why these gas hydrate are more considered in more attention, taking more attention? Why? Because of the flow assurance issues also in the oil and gas industries. As I discussed, the gas hydrate forms ice-like structure, solid structure. So in the oil and gas pipelines, when the conditions are achieved, the phase equilibrium condition, it forms the hydrate-like structures or solid structure, and it can block the pipeline. You can see in this figure, the solid hydrate exists in the pipeline. So we have to must very, very careful towards the management of hydrates. So we have to work on the risk management, and or we can change the equilibrium condition or inhibit the hydrate formation. So we can use some chemicals like salt, glycols, polymers to inhibit the hydrate formations. And we can also transport the natural gas in the form of slurries through the pipelines. Now we are talking about the sustainable energies. So we have to must focus on the carbon dioxide capture and sequestration process. So if we inject, or once we can capture the CO2 gas, if we inject the mixture of CO2 and N2 into under the seabed, where the methane deposits are exist. So as once the phase equilibrium condition for CO2 hydrate achieved, the CO2 molecule can just push the methane molecules, and the CO2 molecule resides inside these cages, and the methane molecules comes out from these cages, and we can extract the methane gas, which is our requirement, the recovery of methane gas. So we can see here the CO2 molecules just push it, we can recover these methane molecules, and CO2 molecules reside in the cages. So we can achieve the CO2 sequestration with the help of gas hydrate based technology. What are the advantages of the solidified natural gas technology? Compact storage, ease of natural gas recovery, extremely safe. How it is extremely safe, we'll discuss in next slides. We can store at 1 atmospheric and 253 Kelvin and environmentally friendly. But there are some challenges we are facing. The condition of hydrate formation condition, some slow kinetics of hydrate formation, or it can increase the time of nucleation. Nucleation means the first hydrate crystal form when the water comes in the contact of gas. So you can see we have a lot of seawater, we have methane molecules, we can form these solidified natural gas pellets. So we are forming these SNG pellets in the laboratory, and the Singapore is working on these SNG technologies in the recent few years. So I just discussed the gas hydrate is extremely safe. How? So I'm going to play a video. We have the Professor Praveen Linga. He is currently Dean of Vice Dean in Outreach Communication of NUS Singapore, and Professor in Department of Chemical Engineering, CHB. And we have Professor Peter Angelos from University of British Columbia, Canada. So you can see, once the hydrate conditions are unstable, the water molecule starts breaking, the cages are breaking, and the gas molecule comes out from these cages, and we just ignite it, and it starts burning because methane is highly flammable. And at the same moment, one water cages breaks, we got the water. So it's a continuous process, one by one. So we are not getting any disaster here. So we can say that it's extremely safe. But that's why it is called burning methane hydrate. As I discussed, we have a lot of methane hydrate deposits around the globe. So we have gas production technologies. We have three gas production technology: depressurization method, where we can reduce the system pressure. Another is to heat the gas hydrates. That means we are increasing the temperature. That means we are disturbing the phase equilibrium conditions. And another is inhibitor injection, where we are injecting the methanol or glycols, by which we also inhibit the hydrate formation conditions. And all these production techniques work as in the extraction of the methane gas from the hydrates. So recently, Japan carried out the extraction of methane gas by the depressurization method. Also, China has also done this job, and India is also working on these technologies to recover the methane gas from gas hydrate from the KG basin, along with the government of India. Now I'm going to show you some experimental results which is performed in the laboratory, which shows how the gas hydrate formed and how it looks like. So we have this PMMA reactor, and we have the aqueous solution, that water, and we have pressurized with the gas. Here the temperature is 274.15 Kelvin. Listen, only just see 1 degree Celsius, and we have 60 bar pressure, and we can see the gas hydrate forms at the interface of water and aqueous interface, gas interface. And as we move with the time scale 10 seconds to 30 seconds, 1 minute, 2 minutes, the gas hydrate start formation occurs in both the direction. It's growing, and we can see that the full reactor is covered with the hydrates. That also shows the rapid hydrate formation. And here we have taken the surfactant, which is SDS, which can promote the gas hydrate formation. We have used the antifoam A with some concentration 0.125% to understand why we are using antifoam, because the surfactant release the foam during the dissociation. So we want to alleviate this foam formation. So we have used the antifoam A and look at the hydrate formation conditions. So when we dissociated with the concentration of antifoam A 0.125, we can see that at 60 minutes, the temperature reached to 294 Kelvin. That means the room temperature, and room temperature, the hydrate will not be stable. The gas and the water molecules separate each other, and we can see a large amount of foam is here. And we have waited for some 1 hour, 2 hour, 3 hour, 4 hour, and we can see the anti-foam work as a elevation agent and elevate the foam formation. I'm going to show you a very interesting video here. Here the condition is methane and water. Only we have water, only we have the methane. Yes, and the condition is 9.5 megapascal and temperature is 1 degree Celsius. Just please have a look. So we can see that at the time scale of 2 minutes or it's going 3 minutes, we have the skin layer formation at the interface, water gas interface. And there's no further diffusion of methane gas. That means there's no further formation of water cages and the methane diffusion of methane gas into the water cages. These are the challenges. For this, we have added the tetrahydrofuran in the stoichiometric concentration. And now you look at the temperature condition, 10 degree. We are moving towards the moderate conditions basically. And we have the pressure is 7.2. And we have formed the hydrate again by using the methane, tetrahydrofuran, and the water. Here you can see within 50 to 1 minute or 2 minutes, the whole reactor is covered with the whole glass vial is covered with the hydrate. So if you look at in this graph, this is the red line represent only the methane and the water in the system. And this, when we use the methane, it forms the S1 hydrates. And when we mix with the THF, it promotes the hydrate formation condition. That means we can form the hydrate at high temperature and lower pressure conditions. And the structure is H2 hydrate. So we can say that the tetrahydrofuran behaves as thermodynamic as well as the kinetic promoter. I just want to look at how this hydrate is forming. So we have just added the red color dye at 5 megapascal condition and 10 degrees Celsius, where the THF concentration is 5.5 mole %. And here is no salt, non-saline system. There's no salt activity. We have taken the pure water. And we can see at 4 minutes, 5 minutes, how this pink color is changing into the white crystals. And we get the solid ice-like crystals called hydrate at 7 minutes. So this represents the rapid hydrate formation. When we have taken the salt concentration, now you can see here the temperature condition 3 megapascal. We are moving towards more moderate conditions, and we also form the hydrates. Now we are adding the 3 weight % of salt because the seawater contains 3 weight % of NaCl, and we also form the hydrate, but minimal amount of hydrate formation we can observe from the morphology of these hydrate formations. We can see that these are the cobalt-like structures formed. If we compare this gas consumption, basically the methane gas uptake, millimole per of gas per mole of water, we can say that at 3 megapascal non-saline or 5 megapascal non-saline are similar. And if we use the seawater saline system, it's almost similar at 5 megapascal. So we have to identify some additives which can work at 3 megapascal also in saline system. But if we use 5 megapascal saline or non-saline system, it's almost equal. So we can say that we can use the seawater for the gas hydrate formation, or we can achieve the desalination process also from this technology. If we look at the dissociation of these hydrate at 5 megapascal and 3 megapascal at 10 degree with saline system and non-saline system, we have observed if we compare these two graphs, 5 megapascal at 10 degrees Celsius non-saline and saline, in saline system, the second row, we observe here 20 minutes only. And when is non-saline, 29 minutes. That represent when we add the salt or the saline system, the dissociation of hydrate is faster. There may be multiple reasons. Could be one reason that it forms not thick hydrate and not strong solid structures because of this salt presence. Similarly, similar behavior we have observed in the 3 megapascal experiment. So now I'm just going to close this today's talk with some of the few points. We can say that a great opportunity to utilize seawater for SNG technology. Gas hydrate is a potential source of clean energy storage. CO2 sequestration can be achieved by gas hydrate based technology. And if we use the optimal ratio of SDS or anti-foam A, that will provide the effectively from the foam generation, and the gas hydrate considered as renewable, and it play an important role in the sustainable energy. These are my publication. I have just shortlisted some important publications here, selected conference publications. Now I will take another 1 or 2 minutes to give you whatever I have discussed till now in a very short, crispy manner in this video. Am I audible?
Yes, sir, you.
I hope this video clip sound is also proper.
Derek, is that sparkling water for me? Thanks.
No. This may look like ice, but it's actually natural gas hydrates.
Natural gas in that small tiny little thing?
Yes, Regine, because this is no ordinary ice cube. It's ice that burns. Renewable ice may sound impossible, but it actually exists in the form of gas hydrates. These ice-like crystals are formed in nature by water and small gas molecules which are trapped within the hydrate structure and begging to be let out. And when you put a flame on the crystal, it catches fire.
Here at NUS Engineering, we are looking for ways to mimic nature and create such natural gas hydrates.
But this is no easy task, as any disruption to the temperature or pressure can cause the gas in the hydrate structure to be released.
Of course, what goes in must also comes out, and hence another area of our research is in developing the technology to tap into hydrates and recover the natural gas with.
Beyond being environmentally friendly, gas hydrates are also non-explosive, safe to handle, and offer a compact mode of storage with high capacity that makes it much more cost-effective to store than conventional methods like compressed natural gas.
In fact, each unit of gas hydrates contains 170 times the volume of gas in standard condition, which is like squeezing the air from a basketball into a golf ball.
Gas hydrates has the potential to be a global game changer. On one hand, the Earth holds between 10 to 40,000 trillion cubic meters of natural gas hydrates, which contain more than twice the amount of energy in all other fossil fuel resources combined. But on the other hand, these hydrates can also worsen the greenhouse effects, as global warming causes the release of even more gas into the atmosphere.
Here in our lab, we are also working on other gas hydrate research projects and on developing innovative applications like desalination, gas purification, and carbon dioxide capture, storage, and utilization.
Conducting such research requires us to think out of the box to develop novel, effective solutions such as gas hydrates, which can certainly play a big part in shaping our future.
This has yet been another episode of Amazing Ideas, Awesome Innovations from NUS Engineering. Thank you for watching and follow us on Facebook.
So both the Derek, the Jong Chong and Regine, both are my colleagues during my PhD journey at NUS Singapore. Now I would like to acknowledge to my Professor Praveen Linga at NUS Singapore and Professor Jiten Sangwai holding a SNG pellet from IT Madras. And I'm also demonstrating the morphology experiments to the Professor Yo Homura, Tokyo University, Japan. And I'm also serving as a reviewer of prestigious 4 journals: Applied Energy, Journal of Natural Gas Science Engineering, Energy and Fuels, and ACS Omega. And this is my email ID. If any one of you, the participants, the audience, the organizers, panelists, anyone has any queries, feel free to write me. Or if you want to collaborate or research work on the gas hydrates, most welcome. That's all from my side. Over to you, Professor Panchal.
Thank you, Gaurav. It was a really great sessions about natural gas hydrate. Let me sum up with the two expert panelist session. Dr. Vishal, he has already discussed about the key components of the smart city, as well as smart living, smart environment, and smart governance. Few topics which have heard, touched my heart, that I came to know that India is the 13th rank among the 70 most water-stressed countries. So we must have to take certain serious action for this. One more thing I have noted down, that 40 million wastewater enters daily into India's this natural reservoir. It's a very big amount. And the people like you, Dr. Vishal, working for this is really needed for the overall smart city development. And Dr. Gaurav Pandey, what a session from your side. Actually, being a domain from mechanical engineering, I was not knowing anything about this gas hydrate. But I like that punchline, eyes that burns. It's a natural gas hydrates, what an innovative technology. I like the sentence that is the golden era of a natural gas we are running today from the days. Obviously, I appeal to all the researchers. It's a very innovative technology and a concept. You can connect with Dr. Gaurav Pandey also. He has discussed many of the things like applications, flow assurance, energy, etc. I must have noted hydrate inhibition and risk management like that. In conclusion, he has also said the opportunity to use seawater for solidified natural gas technology. It's a really innovative concept. Let me start with the few question answer sessions. Many of our participants have a question. It's a question, I think, for both, I think for Dr. Vishal, how IOT can increase the capacity of STP. What will be the methodology?
Okay. So basically, IoT, what IoT does, IoT, we are implementing IoT sensors in the STP. So what sensor does? A smart sensor send the data to the controller, and then we can, by the help of controller or microcontroller, we can just manage the parameters as what we want. If suppose in the water, this is not, we are not increasing the volume of the plant. We want to just increase the capacity, the treatment capacity. Like if suppose water having the different contaminants, the concentration of the contaminants is very high. So with the help of IoT sensors, we can predict if suppose the DO of the water is very high. So we can, the sensor will just predict the data and send to the cloud, or with the help of controller, we can manage. So what happens actually in continuous plant? So if suppose the contaminant concentration is very high, so with the help of IoT sensors, we can just control. With the help of IoT sensor, we can just get the data and control the desired concentration of the contaminants. Like we can mix the water to down the concentration of the DO value. So basically, with the help of that, we can just save our instruments. Like if we are using a membrane, as I told in the membrane bioreactor, so if the contaminants concentration is very high, the pollutant concentration is very high, so ultimately it will be deposited on the membrane surface. So that will be the cause of falling, external falling or concentration polarization. So if initially we have the data like the concentration TDS value is very high, so we can initially control with the help of controller. So the treatment capacity will be high because we have already controlled. So in that mean IoT can be very much helpful for to increase the treatment capacity.
Thank you, Dr. Vishal, for a descriptive answer. Here is a question for Dr. Gaurav Pandey. Pandey sir, how is gas hydrate useful for India, as we have very few petroleum resources like Assam and Gujarat state only?
Okay, thank you for the nice question. As we know that we have a lot of methane hydrates in KG basin also. I just want to let you know who asked this question. Please go and look at the survey and find out the gas hydrate deposits in India. So we have a lot of gas hydrate in KG basin. Along with the US and ONGC and Government of India, we are working on the extraction of gas hydrate using these three technologies, that basically depressurization, whatever the technology followed by the Japan and China. So we can choose the optimal usage, minimization of cost. We can go for the extraction of gas hydrate. So sorry, the methane gas recovery from these gas hydrate by using the depressurization method. Or nowadays, as the researchers are working on the combination of depressurization as along with the thermal stimulation method, where we are increasing the temperature. So we can go with this. So as I discussed, we have a lot of deposit of methane hydrates around the globe. So in the globe, India also exists. So we have a lot of methane hydrates. And I can say that definitely once we are able to recover these methane gas from these hydrates, we can go for another 200 to 300 year with the energy.
Sir, one more question for you also. How gas hydrates contribute lesser greenhouse gases compared to conventional fossil fuels like petrol and diesel? Isn't methane also a fossil fuel? It's a question from one of the participants.
Yeah, as I discussed, the natural gas hydrate emits the half of the carbon emission as compared to the other fossil fuel. So that's why we are saying that it is considered as clean energy as compared to other fossil fuels.
Okay. So thank you both of the panelists. Let us moving towards the conclusion of the session. Honorable our Hemant Thackeray sir, President, respected Sudhir Kumar Kalla, Chairman of Electrical Division Board, Chairman Kate G. Ranganath sir, our Chairman Dr. Jignesh Vagasia, my most valued invited panelists Dr. Gaurav Pandey and Dr. Vishal Kumar, Rachna Datta from IEI Headquarter Kolkata. Ladies and gentlemen, I, Professor K.D. Panchal, Senior Faculty at Government Engineering College, Surat, and Subzonal Officer, Placement Cell Education Department, Government of Gujarat, and Honorable Secretary as well, on the behalf of South Gujarat Local Center, Surat, Gujarat, extend a very hearty vote of thanks to all speakers, all panelists for gracing your important work, research work, and your domain work, sharing with us your deep knowledge and opinions today. Thank you. I may like to express also my sincere thanks to Dr. Hemant Thackeray, President IEI, Dr. G. Ranganath, Chairman Kate, Dr. Sudhir Kumar Kalla, Chairman Electrical Division Board, for their valuable presence during the webinar today. Respected Chairman, ladies and gentlemen, once again, I want to state that we are all almost grateful to all panelists on this stage. Last but not least, I thank you all the participants for being with us this evening. It is being a great pleasure. Thank you. Jai Hind. Jai Bharat. Thank you.
Thank you, everyone.